All right, this is Unit 5. In Unit 5, we're going to be looking at triangles. We're going to be looking at how to apply theorems about properties of triangles to find measures, writing equations of and using special segments in triangles, and finding points of concurrency. So this lesson is applying properties of exterior angles and special triangles to solve problems. So this is review information. You should already know this, but you can classify a triangle by the lengths of its sides or by the measures of its angles. So when you classify by sides, we have equilateral, where all sides are equal, isosceles, where at least two sides are equal, and scalene, where no sides are equal. We can also classify by angles, equiangulars when all angles are equal, acute, all angles are acute, right, we have one right angle, and obtuse, we have one obtuse angle. So we're going to look at how to use properties of triangles to solve for missing measures. So part one, we're going to talk about an exterior angle in a triangle. An exterior angle of a triangle is formed by one side of the triangle and the extension of an adjacent side. So basically an exterior angle is on the outside of the triangle. So the exterior angle theorem tells us that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So let's talk about what remote interior means. It means the two interior angles of the triangle that are not adjacent to the exterior angle. So looking at this picture in example 1, 1 and 2 are a linear pair. They are adjacent, and since they're a linear pair, by the linear pair theorem, we know that they add up to be 180. And if you think about the triangle sum theorem, we also know that the interior angles of a triangle add up to be 180 as well. So if you think about those two things, then you can see in these two equations that the measure of angle 1 has to equal 80 plus 40. So 80 and 40 are the two remote interior angles because they are not adjacent to angle 1, which is our exterior angle. So to find the measure of angle 1, the theorem is telling us that all we have to do is take 80 plus 40, and that gives us the measure of angle 1, 120 degrees. Okay? All right, in example 2, it says in triangle XYZ, we know that angle X is 63 degrees, and angle Z is 64, and we want to find the measure of angle ZYR. Angle ZYR is this exterior angle right here. So based on that theorem then, the measure of angle ZYR should be 127. 64 plus 63. The sum of the two remote interior angles gives us the measure of the exterior angle. So yes, you could add 63 and 64 and subtract that from 180 and get the interior angle, the third interior angle, but then you have to subtract that from 180, so you're just doing extra work that you don't have to do. And then when it comes to problems like example 3, we have algebra in all of our angles, and so we can't use that method. We have to use the theorem to help us solve it. So for this one, it says that the measure of angle G is 11x minus 2 degrees, and the measure of angle F is 8x plus 4, and the measure of angle FEH, which is our exterior angle, is 17x plus 10. And it says find the measure of angle F. So we're going to take the sum of the two remote interior angles, add those together, and we know that that should equal the measure of the exterior angle. Okay, so let's combine like terms, and we get 19x plus 2 equals 17x plus 10. So solve that, subtract 17x to the left, subtract 2 to the right, and we end up with x equals 4. Now it says find the measure of angle F. So you want to make sure that you plug it back into angle F, which would be 8 times 4 plus 4. So 32 plus 4 gives us 36 degrees. All right, so that's how we use the exterior angle theorem, is we add the two remote interior angles equals the exterior angle. All right, so let's classify this triangle by sides based on what we talked about at the beginning. It has two sides equal, therefore this is an isosceles triangle. And when we talk about an isosceles triangle, the two sides that are congruent to each other are the legs. So AB and AC are my legs. The third side that is not congruent would be our base. So segment BC is our base. The base angles are the angles across from the two legs. So angle B and angle C would be our base angles. And the vertex angle is the third angle, or the angle that is in between or formed by the two congruent sides. So our vertex angle is angle A. So sometimes we'll be given problems where it just describes the triangle and we don't have a picture, and so you'll need to know how to draw it and label it based on the parts. What are the legs, the base angles, and the vertex angle? So we have these two theorems based off of isosceles triangles. The isosceles triangle theorem tells us if two sides of a triangle are congruent, then the angles opposite of them are congruent. So our hypothesis is two sides of a triangle are congruent. If that's true, then we know the conclusion, the angles opposite of those are congruent. And the converse of that is just when we switch the hypothesis and the conclusion. So if two angles of a triangle are congruent, then the sides opposite of those angles are congruent. So the first theorem, the isosceles triangle theorem, this is what it's telling us, that if I know segment AB is congruent to segment AC, then I know the angles opposite of those are congruent, so therefore I would know angle C is congruent to angle B. And then the converse of that is saying this: if I know angle C is congruent to angle B, then I know the sides opposite are congruent. So therefore I would know segment AB is congruent to segment AC. So it's just the converse of the statement above the switch. All right, so let's use that information to help us solve some triangles. So example 4, I want to find each angle measure. So it's telling me in number 4 that is an isosceles triangle, because these legs are congruent, and the vertex angle is 30 degrees, and we want to find one of the base angles, the measure of angle F. So I know that the base angles should be congruent based on the isosceles triangle theorem. Therefore, we can add the two angles. I could label both of those X, and then I can add all three angles using the triangle sum theorem. I know that they all add up to be 180. So let's subtract 30 and then divide by 2, and I get X equals 75. So my two base angles are 75 degrees. All right. Number 5 is also isosceles, and we know the legs are congruent. So using the isosceles triangle theorem, we know that the base angles would be congruent. So let's set 6y equal to 8y minus 16. Subtract 8y to the left, divide by -2, we get y equals 8. But on this one, we want to know the measure of angle P. That should say P. All right, so the measure of angle P, we're just going to plug it in. So we're going to do 8 times 8 minus 16, or we could plug it into 6y and do 6 times 8, which gives us 48 degrees. All right. Now let's see if we can use the converse of the theorem. So in number 6, I'm given the lengths of all the sides, or I'm given algebraic expressions for the lengths of all the sides, and I know two of the angles are congruent. Angle A is congruent to angle B, so those are my base angles, and therefore by the converse of that theorem, I know that the sides opposite of those angles should be congruent. Therefore, I know 2x minus 4 equals x plus 5, and then we can solve for x. We get x equals 9, but we want to know the length of AC. So AC is 2x minus 4, so we need to do 2 times 9 minus 4, and that gives us 14. Now let's look at number 7. we know two of the sides and two of the angles, and we're trying to use the converse of the theorem, which means we need to know something about the angles in order to know something about the sides. We want to find the measure of side GH. So let's think about this. We know two of the angles in the triangle. Can I find the third angle? Yes, I can add 56 plus 62. Let's go ahead and give this an X. I can add 56 plus 62 and subtract that from 180, and that will give me the third angle in the triangle. So I've got x plus 118 equals 180. Then I know x equals 62. So if this angle is 62, what do you notice about this picture? It's a little bit deceiving, right? You would think the base angles are angle G and angle H, but in this case, when we find the measure, my base angles are actually angle F and angle H. So the sides across from those should be equal, making GH 42. So be careful and don't let your eyes deceive you or your picture deceive you, or if there's not a picture, you just have to go based off of the parts or based off of the theorems. All right, so part 3, let's classify this triangle by sides. Notice that all these sides are equal, so this is equilateral. And let's classify it by angles. We would say it is equiangular. So all the sides are equal, and we would know all the angles are equal as well. So if all of the angles are equal, and we know all the angles add up to be 180, that means each angle would be what? Yes, 60 degrees. So if it's equilateral, it's equiangular. It's equiangular, it's equilateral. Okay, so those are these corollaries. The equilateral triangle corollary says if a triangle is equilateral, then it's also equiangular. And the equiangular triangle corollary is if a triangle is equiangular, then it is also equilateral. So in example 8, it says triangle JKL is equiangular. We know all the angles are equal, so they're all 60, but it tells me to find the side length, side JL. So if it's equiangular, we know it's also equilateral, therefore we know JL is equal to KL. So we set those two things equal to each other and solve. So we get 2t equals 9, therefore t is 4.5. We're not looking for t, we're looking for the length of JL, so we want to plug that back in. So we want to do 2 times 4.5, which is 9, plus 1 gives us 10. All right, so those are fairly easy to use. Equilateral means equiangular, and vice versa. All right, the last one is a proof, and yes, let's try this proof using some of these theorems or corollaries that we just talked about. So in this problem, we have a picture, and we know we are given the following information. We know that S is the midpoint of segment RT, and angle 1 is congruent to angle 2. And we want to prove that segment QR is congruent to segment ST. So let's go ahead and look in our picture. I know angle 1 is congruent to angle 2 based on the given. And I also know S is the midpoint of RT. So what does that tell me? If S is the midpoint of RT, then I know what is congruent. Segment RS is congruent to segment ST. Okay, and then we'll see what we can do from there to prove that QR is congruent to ST. So let's start with our first given. I know S is the midpoint of RT. And that is given to me. And what did I mark in my picture that I know since S is the midpoint of RT? I know RS is congruent to ST. What's the reason I know that? Definition of midpoint. Good job. All right, next, let's put the next given. Angle 1 is congruent to angle 2. That's given to me. And I'm trying to prove something about segments, not about angles. So how can I use angle 1 as congruent to angle 2 to come up with something about the segments? Good. You should be able to use the converse of the isosceles triangle theorem to state that QR is congruent to RS. So I can say that QR is congruent to RS because of the converse of the isosceles triangle theorem. And then if I know RS is congruent to ST and QR is congruent to RS, then by the transitive property, I know QR is congruent to ST. And that's what I was trying to prove. By transitive property of congruency. And there you go. That's how you can use isosceles triangle theorem or its converse to help you prove something about triangles. All right, that was topic 5-1, triangle property.